Hi, in this video, we'll be going over week 5's homework on functions through the coin flip exercise. To start our code, we write import random. This allows us to use the random program throughout the rest of the code. Next, we need to define our function. I've labeled the function as coin flip. Inside coin flip, we need to set a variable, which I've named num, to equal a random integer 0 to 1. This is where we use the random program that we imported. We write random.randint and then in parentheses 0, 1. This means that inside our function, it will flip to 0 or 1 randomly. After doing so, we need an if-else statement. We write that if the variable num is equal to 0, then that means if 0 is flipped, then we return heads. This means that if the condition is met where 0 is randomly flipped, then 0 is now associated with heads. Otherwise, we write else colon and then return tails. This means essentially that if 1 is generated, then the function returns tails, meaning 1 is associated with tails. Now that we have written our function, we can now begin setting up our simulation. We start by setting the number of trials, which we have set to trials equals 10. Then we need to write two more variables to be the counters of the amount of heads that are flipped and the amount of tails that are flipped. Since we haven't started anything, they will be both set to 0. So heads equals 0 and tails equals 0. Now we can start the simulation. We do this by creating a for loop. So for I in range of trials, this means that for every index in the range of trials, which is 10, we will now use the coin flip function 10 times. Now the coin flip function can help flip the coins for us. Next, we need to use an if-else statement to mark what happens when heads and tails are flipped and how that affects the counters. So in the condition, if coin flip is equal to heads, that means if heads is flipped when running the function, then we need to add 1 to our counter. We can do this by writing heads plus equals 1. This means that 1 will be added to the current value of heads. Otherwise, we can write else and then tails plus equals 1. This means that if tails is flipped, then we can add 1 to the current value for the counter of tails. This way, after the for loop is complete, the counters will now be set to the values that match how many times the heads was flipped and tails was flipped, respectively. Now we can print the proportion of each coin flipped. And don't forget to cast number variables to the string. We can do this by starting with heads. We would write print in parentheses, in quotations, proportion of heads flipped, colon, outside the quotation, we would write plus and then str in parentheses heads over trials. This will take the value that of heads over trials and set it equal to a string. This way, this line of code will run. Then we do the same thing for tails. When we run this program, it will now print proportion of heads flipped and then the ratio of heads to trials and proportion of tails flipped and the ratio of heads to trials. Now let's try to run this program. And as you can see, it printed the proportion of heads flipped and the proportion of tails flipped based on our simulation. Thank you, and that is all for week 5.